Okay, so we're going to look at another example where we use the definition of the derivative to show that the derivative of a particular function is whatever somebody tells us it is or we think it is. All right, so again, the point of the definition is that any shortcut rules that you may have learned for finding derivatives all came from that definition. So we're going to use that definition to make sure we're clear why those shortcut rules. We're going to use that definition to make sure we know why those shortcut rules are what they are. Okay, so the first thing we need to do is remember that definition of the derivative. So hopefully when I say that, you think about something that involves a limit and an h. So let's go ahead and write that down. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h for all values of x for which that limit exists. So I'll put here whenever this limit exists. Okay, so that definition you need to have memorized. It's an important definition for a Calc 1 student to know. Okay, so the directions on this problem say to use that definition to show that the derivative of our function f of x is whatever it says that it is. So we want to start with that definition. When you're doing a problem like this, good idea to just write down that definition as the very first step. That way, even if you mess up something else, you got that much of it right. Okay, and then you're just going to follow that definition through and do what it says for the function that you're working on. So don't forget to write the limit out front. Limit as h approaches 0. That should really be on every step until you get to the end and you can evaluate your limit. All right, first of all, it says f of x plus h. So I'm going to look at this function f of x, and that's telling me to put x plus h in place of x in the function I have. 3 over x plus h, the quantity squared, minus f of x. So f of x is just the original function. And then all of that over h. Okay, so here I've got fractions within fractions, which are kind of a mess to work with. I also need to evaluate this limit. So we might think about whether I could just go ahead and evaluate the limit and use substitution shortcut theorem. Unfortunately, that should be pretty quick for you to recognize that you can't do that. I have an h on the bottom of this fraction. I can't be substituting in h equals 0 to the bottom of that fraction. So I have to think through some algebra that I might be able to do to simplify this. So when we have a fraction within a fraction like this, that's called a complex fraction. There's a lot of ways to simplify them. So if you think you know some other ways to simplify it and you're not sure if it's right, check. Send an email to your teacher or ask a tutor or something like that. Make sure that the algebra is correct. I'm going to go ahead and use a strategy that I like, which is to multiply the entire overall fraction by the common denominator of these two little fractions that are within the larger fraction. So the common denominator here would be x squared times x plus h, the quantity squared. So I'm going to go ahead and multiply through by that. I can't just go around and start multiplying pieces of fractions by whatever I want, though. I have to balance that. So if I'm going to multiply by this on the numerator, I have to multiply by the same thing on the denominator. So that what I'm multiplying by is really a form of 1, not changing the original problem, just cleaning it up a bit. Okay, so I'm going to take this expression, x squared times x plus h, the quantity squared, and I'm going to distribute that through to these two fractions on the numerator here. Okay, so don't forget to write that LIM in front. That's important every step till we're at the end. All right, when I take the x squared times x plus h and I distribute it to the 3 over x plus h, the quantity squared, I'll have some nice cancellation. That's the entire point of this. The x plus h, the quantity squared on the denominator here will cancel with the x plus h, the quantity squared that I'm multiplying by. So for that part, I'm just going to be left with 3 times x squared. Okay, now I want to go ahead and distribute to the second term on the numerator. So this time I'll have the x squared cancel with the other x squared, and I'm going to be left with 3 times this entire x plus h, the quantity squared. Okay, on the denominator here, no cancellation, so I just have all of that. H times x squared times x plus h, the quantity squared. Okay, so when we do any of these problems using this limit definition of the derivative, one of the things that should happen is that we get lots and lots and lots of simplifications. So you just need to make sure that you do correct algebra to get that simplification. I'm going to go ahead and multiply out the x plus h, the quantity squared, and then distribute through this minus 3 and see what happens on the numerator here. Okay, so when I multiply out x plus h, the quantity squared, that really means x plus h times x plus h. Okay, so I want to FOIL that out and think about all the terms that I get. You might know some shortcut rules for doing that, but I'll get x squared plus xh plus another xh, so plus 2xh plus h squared, all over all this denominator that I have. Okay, so I would like to be getting some cancellation here, so far not yet, but I think one more step and we'll be ready to go with that. Okay, so I'm going to go ahead and distribute through this minus 3 that's times this entire parentheses on the numerator. I do have to be careful to make sure I'm distributing through the minus sign as well. So I'm going to write that as plus a negative 3 just to remind myself to distribute through that minus sign. Okay, so I have 3x squared, and then I'll have minus 3x squared. Ooh, that looks promising. Minus 6xh minus 3h squared all over all this stuff. Okay, fun part next, canceling. 3x squared minus 3x squared, so that's good. You might notice that for these terms I have left, then there is a common factor of h, or even negative 3h if I want. I'm going to go ahead and factor out just the h though. I made a mistake. I'm going to fix that. Okay, the reason I factored out only the h is because I noticed that I had this factor of h on the denominator that I was going to be able to cancel with that h I factored out on the numerator. Okay, so I think we got about one more step here. All right, on the numerator, minus 6x minus 3h all over x squared times x plus h, the quantity squared. Okay, so at this point, I have a limit, and we might notice we can actually use substitution shortcut right now. I can actually substitute in h equals 0 at this point. Remember, that's not really what a limit is asking about, but sometimes you can use that shortcut to evaluate limits. So at this point, after I canceled the h on the denominator in my previous step, I can substitute in h equals 0, and I should be able to finish the problem and get what they said I was going to get. Okay, so on the numerator, when I substitute in 0 for h, I just get minus 6x. On the denominator, I will have x squared times x plus 0, the quantity squared, so that will also be x squared. So I have an x that cancels from the numerator and the denominator, and I'm left with an x there. So it looks like I'm left with negative 6 over x times x squared, so negative 6 over x cubed, which, yep, that's what it said we should get. So good, we got what we were supposed to get. Okay, this requires a lot of practice. It's a lot of algebra in the middle. Make sure you're doing that okay. Also make sure that these limits are written on every step until at the end where you're ready to evaluate that limit. Remember, we know what the answer is here. We were told what the answer is here. What this problem is asking us to do is show the work correctly that justifies that answer. So all this notation is important.